Okay, this is a walkthrough of the mechanics paper from the Edexcel, the 2019 sitting, the A2 paper, and we've got question 1 here, which gives us a equation for the velocity in vector form, and it asks us to find the acceleration of the particle when t is equal to 4. In order to find the acceleration, that's the rate of change of velocity, which we can find by differentiating this. Now you're absolutely fine to differentiate velocity and displacement and even acceleration when it's in vector form. That's fine. So I'm going to go ahead and differentiate the velocity to get the acceleration. And that's going to be 6i, so the I doesn't differentiate, it's the variable is t, so that's going to be 6i minus what we get when we differentiate 5t to the power of 3 over 2. So that's just the same as when we do the normal pure differentiation, so that's going to bring the power to the front, which is going to be negative 15 over 2 t to the power of a half, and that's in the j direction. We're then going to substitute in the value of t, which is 4, and we're going to get that the acceleration is equal to still just 6i minus 15 over 2 times the root of 4, which is 2j. So that's going to be 6i minus, the 2's will cancel, so minus 15j, and that will be meters per second squared. Now we're going to leave it in this form because they presented the velocity as a vector. We're going to give the acceleration as a vector. There's no need to find the magnitude. If it wanted magnitude, it would have asked for it. It would have said find the magnitude of the acceleration. So we are fine to leave our answer like that. We should leave our answer like that. And then for part B, it asks for the position vector of p when t is equal to 4. We know that it starts at position vector minus 20i plus 20j, so it's going to start here and move to a new position after 4 seconds. So the first thing we're going to do is we're going to work out how to get the position vector. Now that's linked to displacement, which means we need to integrate the velocity this time. So I'll call that s for displacement, the integral of 6 ti minus 5t to the 3 over 2 j. When we integrate that, we're going to get 6t squared over 2, so that's going to be 3t squared I, minus, integrate this, we're going to get 5t to the 5 over 2 divided by 5 over 2. That's going to cancel and just give us 2t to the 5 over 2. I'll put plus c, I'll plus some vector c. Now the reason that's important is because we know we can work this c out. When t equals 0, the position vector needs to be minus 20i plus 20j. So that gives us the c vector, that gives us the initial starting vector. So we can say that the displacement vector or equation is then oh, that's my j here. And then we can write minus 20i plus 20j meters. And then we can substitute when t equals 4 to get the actual final displacement at that point. T squared is going to be 16, 16 3 is 48. 4 to the power of 5 over 2, that's going to be 2 to the 5, which is 32 times 2 again is 64. And then minus 20i plus 20j, which will give us 28i and minus 44j.